Hello everybody. So my last video about the problem 49 chapter 27 was with no audio. I'm really sorry about that. One of my students gave me a heads up and so now I will just show you guys how to do it, this one, okay? So let's try to think about this problem here. So guys, this problem here, it's a good one because it's going to be about a circuit with resistors and an EMF 5.0 volts, an ideal battery, and with three resistors here. Okay, so the first thing that we need to remember is how we can do it with resistors in series and in parallel. And if you remember, we just need to use these two here for series and this one here for parallel. Okay? So now let's think of what the problem wants us to do. He wants us to calculate what is the amperage or the current that this ammeter here is reading. So what is the current here? Well, the current here, do you agree that's going to be the same as I3? Because the current that will pass through I3 or coming this way, right? The current is coming this way. So the current that will pass a this ammeter here will be the same that will pass through R3. Agreed? Okay. So if you remember, the Kirchhoff's loop rule means that if I do the algebraic sum of all potential or potential change in the circuit, we must be equals to zero. So this is what we have here, guys. Take a look. But wait a minute. Why you are using only I3 and R3 and not R2 and I2? Well, because between these 2 points, A and B, we have the same potential difference. That means it doesn't matter if I go this way here or if I go this way, the potential difference will be the same. So what means it's going to be, it will be like if I have the V1, V2 potential with R2 and I2, it will be the same that it will be if I do with V3, with R3 and I3. So it's the same because the resistance will be different in this both case, in this two case here, and the current will be different because they need to match the same potential difference. Okay, so because I want this current here, so I need to use I3 and R3. Okay, and the current here will be I1 R1 because we'll be following this direction. So my equation, my Kirchhoff's loop equation will be this one here, the EMF. Okay, and the difference from the potential difference from I3 R3 is taken out and R1 I1 R1. You got the idea, right? But my problem is I want to calculate this dude here. But the thing is, I have EMF, I have R3, I have R1, but I don't have I1. So I need to calculate I1. So, but what is this current here I1? Well, if you remember, the current the current that is coming this way, we need to have the current outside here. Okay? So, because of that, the current that is entering to be spanned here, to be used in this resistor equivalent here, R2 and R3, it's going to be the same in R1. So we can write this equation here using the same mindset of the Kirchhoff's loop. We have the EMF on this one because of this guy here, and will be the current I1 R1, this one here, and minus the current I1 because it's going to be the same, right? With the equivalent resistor with this part here. Well, the resistor equivalent for this guy, it will be this one here. You know that, right? Because you remember this one here, the parallel resistors, right? So we can just do some algebra here and we're going to get this guy. The resistance equivalent will be R2 R3 times R3 divided by R3 plus R2. Okay, so we can just do algebra and we can separate I1 because these guys will be the same, remember? So we're going to find I1 as 1.14 amperes. Now my life is super easy because now I just need to plug it in, this I1 back here in my first equation. And guess what? Boom, we got I3. So our I3, it will be 0.45 amperes. Okay? So the current I3, the current that will be measured here will be 0.45 amperes. But now the problem keeps going and shows like, okay, so now the ammeter and battery are now interchanged. That means now the battery will comes to the place where the ammeter was, and the ammeter came to the place where the battery was. So now what I have is, do you know if they're gonna if we're gonna measure the same thing, the same current? The problem say yes, we're gonna measure the same thing. Now prove how. Okay, so we need to start with the same idea. So take a look here. Take a look at this equation. We're gonna have the EMF. Now the current will be going this way. Agreed? So the current is going this way. So now the current will be coming this way with this parallel here. Agreed? And when the current is coming this way here, so we're going to have I1 coming this one here. Take a look. And here we're going to have I3. Agreed? Okay. So our equation will be the EMF minus I3 R3, this guy, right? Minus I1 R1. Do you remember parallel circuits, same potential difference? Do you remember that? The same case here. And we can apply the same mindset. So my problem again is to calculate the I3, okay? My problem is to calculate the I3. When I do that, what I need to do, what I can do, to be honest, is just need to use the same mindset that we use for this guy. What we did here, well, we knew that the current that will be coming to this place will be the same that will come out and feed R3. So we can call this current I3. We can use this equation here. Take a look. The EMF minus I3, the equivalent resistor from this guy. Now we're going to have to calculate the equivalent resistor for this set here. And minus I3, R3. Well, we can use the same mindset. So just to give an example, we're going to use equivalent, okay? We can use, we need to calculate R1 and R2. So it's going to be R1 plus R2, and to be honest, R1, R2, R2 plus R1. We're going to, just switch this guy here, just change here. So it's going to be R equivalent, and going to be R1, R2, and R2 plus R1. Okay? So we just need to plug it in here, this, and we can calculate I3. Calculating I3, we will plug it in back in this guy, and we are able to calculate I1 and see that this guy here will be 0.45 amperes, the same than I3 before here. So we can change ammeters, and for this circuit here, we can change we are able to change the ammeter with the battery, and we can calculate, we will have the same current. Okay, so guys, thank you for the heads up with no audio. Please let me know if you want some specific problem from Halliday or any other book about physics. Okay, so I will try to do it. Okay, so just let me know. And by the way, let's do physics, guy. Let's study physics. See you later.